I'm John Crucione. I'm a professor of biomedical engineering at Texas A&M University, and I'm the vice dean for the engineering medicine program. I'm here today to discuss the results of our testing of DIY style N95 masks. The reason we decided to do this, I usually do cardiovascular devices, but my colleagues at the Texas A&M Health Science Center asked us to. They were looking at their supply of N95 masks, and they were looking at their rate of usage for non-elective emergency procedures, and they were seeing a gap. So they were seriously considering using DIY style masks. So it was high time for us to seriously consider the performance. And that's what we did. So we did two basic performance things, and mostly focused on fit. So the filtering material is important. The filtering material, if you don't have the right filtering material, you're not going to get filtering. But fit is even just as critical, because you could have the best filter, but if it doesn't fit your face, particles are going to come right into the gaps. So we focused on fit, and the masks you see here are different styles, and they're arranged on performance. These are the 3D masks. We use the Montana style. We did some DIY masks, and over here we have the N95 mask. Okay, so let's start our discussion on the N95 masks. So these masks are rated to basically filter out particles provided they fit. Now there are multiple different styles of N95 masks, and if you do any sort of training for BSL level 3, you're required to do quantitative fit testing, and you will discover that some of these styles will not fit your face. They will pull different styles for you to try, so that they can find the mask that best fits for you. Now we call this the dome style. Okay, this we called the left-right fold style, and this we called the up-down fold style. Now for our DIY, we failed to make the dome style because we were starting with 2D filter material, and we weren't heat pressing or any sort of using advanced forming methods. We could not get rid of folds in the material, which would then leak. For the up-down fold style, we had difficulty with pleats. We had very thick, filter material. In fact, we used 4 layers of MERV 13. We couldn't get that to pleat well. So we ended up doing the left-right fold style, and that's what you see here. But before we discuss that, let's look at the performance on this side. So this is the 0, okay? I call this the noise floor, right? Because the measurement is basically just as if you weren't wearing a mask. And the surgical mask leaked a lot along the sides. That was to be expected. That leak probably helps you breathe in surgery, or at least inhale. The 3D masks, they also leaked a lot. This is the Montana style, which is one of the popular ones out there. It did not fit my face, okay? It probably fit my face for 75% of it, but the other 25% leaked like crazy, and sodium particles, not sodium, salt particles rushed right in, sodium chloride. And so this, the performance was suboptimal. This TPU style did better. It fit my face better, but that alone just wasn't enough. When I moved, when I talked, gaps would open up, and the sodium chloride particles would rush right in and be detected on the inside via this grommet. All right, now another problem with these, if I pushed it against my face and I used my face as a gasket, there was not enough filter area. Okay, it was very difficult to breathe. The filter area has got to be increased in this style of mask. Now I put these masks, these left-right fold DIY masks, kind of halfway between, because they're halfway decent. All right, they weren't at the noise floor, and they weren't above the N95 standard. We did not reach the N95 standard. Okay, but they were at least filtering material and fitting accordingly, and then they passed the qualitative fit test. So we're going to show you how we made them, all right, for the hopes that you can do better or repeat our results. This is a scientific method. Proof is only standard established with repetition. Before we show you how we made our most successful mask design, I wanted to discuss about the material choices and what worked. We don't have near enough time to show you what didn't work. There were a lot of those. Now, because we intended to do some self-tests and put these masks on our face and breathe through them, we wanted to keep contamination level to a minimum. So we used a all-purpose cleaner with bleach to clean the surfaces, and we used a surgical mask and gloves for assembly. Now, some of the tooling you'll need a scissors and a wire snip and a ruler. To assemble the device, we actually used 2 staplers. So one stapler for doing flat staples on the desk, and then a handheld stapler for doing staples on nearly the finished mask. Now, to really help us guide the staples, we put a black line where the staple would go, sort of on the back side. Particularly because you need to staple from inside the mask to out, so that you don't have the pointy ends of the staple pointing towards the face. So this line is actually really critical, and a nice handheld stapler we felt was essential. All right, now with regard to the materials that we make it out of, let's start with the filter material, because if it doesn't filter, it's not a good mask. We used MERV 13 rated AC filter material, which is a polyester, which is fairly safe. Now we didn't even consider fiberglass material filters, because fiberglass should not get anywhere near your face. The fiberglass particles can get in the lungs and damage them, so we stuck with polyester. But still, this is a mat, and polyester fibers can break off on a mat. It's not woven, so we covered the inside and out with a woven fabric. Now this is what we found best, was a sheer drapery. Okay, it's a really tough woven polyester and available everywhere, of course. So this is what we covered it, the skins, basically on the inner and outer of the mask. Now for the nose bridge, to form it to the nose, we found 3 things worked fairly well. Probably the best, in my opinion, was this galvanized roofing material. It's called flashing. Okay. Now they sell aluminum flashing, but the aluminum flashing was too springy. We couldn't get it to form to the nose bridge. The galvanized flashing could form. All right. Now that's the opposite for the wire. For the wire, this is electric fence wire, 17 gauge electric fence wire. We felt the aluminum wire was best, but the galvanized wire was a no-go because it was just too rigid. Another option is the pipe cleaner. Now, the pipe cleaners are okay, but they're a little too weak when it's just one layer. All right. To make it stronger, you really have to double it up and twist it together, and then it will have the right amount of rigidity. All right, for the straps, we just used a thick yarn. It's just easiest, available everywhere. Be careful with thin materials, and nylon tends to be very slick. It's tough to tie behind your head. Try to tie it behind your head before you go ahead and use it. Of course, elastic's really good. We found an elastic cord was nice. Elastic strap was really good. Lots of options there. For the final steps, we packaged the masks in a bag that is intended to go into the oven, all right, or into something hot. This is actually a slow cooker liner, so it's intended to get hot and it won't melt at temperatures of slow cookers. They also make oven bags that can go in the oven. And then we use strapping tape at the final part, and we have a label. So all good medical device development requires a very tight consideration of the label. Now this is not a medical device, but we're still labelers. That's in our blood. So we make labels for things we make. The first step is to cut the materials. We have the filter material. We cut it. We need 4 layers that are 9 by 6. Now this is actually 6 by 18. So when we fold that over, you don't have to do it 6 by 8. You can do 4 that are this. it becomes 4 layers of 9x6. Now, the long dimension of the 9x6 should be the pleat. Okay, we found it's difficult to fabricate the other steps if the pleats run this way in the short dimension. Now, we chose 4 layers of MERV 13. Now, for the shear, the drapery, we need 1 that is 9x6, and then we need 1 that is 9x8. This is going to be the inner one that we end up folding the edge over towards the outside, but this will be the outside skin. In this step, I'm going to show you how to make this. All right. And what we do is we start with 4 layers of the filter material. All right, that's again, it's 9x6 inches, and we'll lay it on top of the big piece, right, of this shear, and then we'll put the small piece of the shear over that. And I'm pushing down on the filter material to keep it flat. Otherwise, it's just going to want to pop up because of those pleats. Now I'm going to put a staple in the 4 corners. All right, I'm going to try to get the staple, fairly close to the end that I'm comfortable with, but I want the staples to be parallel to this short dimension. Two sides. Come over here, reposition it. So there you go. That's this step. In this step, we're going to end with the finished piece that looks something like this. So you start with that first layers of material, and then we're going to fold it. Now, to fold it, flip it over and make sure the long piece is on top. All right, and then you can fold it. And when you fold it, then the long piece will be in the inside. Okay, and the short skin will be on the outside. All right, now after I folded it, here's the overlap, the long part. I'm going to go to the opposite side here. And where this staple is, I'm going to start stapling at the top of that staple towards this corner. And I'm going to put in 5 staples. It's going to be a row of 5 staples that are fairly close to one another. All right, so I start at the top of that staple. 1, 2, 3, 4, 5. Now, I'm stapling pretty hard so that it really makes a good seal, and the ends of those really dig down in the material. If you staple kind of weak, they may not go all the way through. All right. And then I'm going to do 2 staples up this folded edge. So 1, 2. All right, and then I'm going to do a staple that starts at the top of the second one and heads towards the 4th staple end. So between the 4th and 5th staple. So I'm going to have 3 staples that go towards that. So again, I start at the top of the second. 1, 2, 3, like that. All right, now let's go to this end. So on this end, we're going to do 1 more staple up. Oh, that was a missed staple. That's part of the problem with stapling hard. You get a lot more missed staples. And after we do the second one up, now we're going to do one perpendicular to that. But above it. Okay. And then I do one to the side, slanted, like that. All right. Now, this top staple is very important. So it actually prevents this from opening up. when it goes on the face. So we actually do 2 staples there, but we flip it over to do the second one. All right. And we do it at roughly the same location, like that. And what that will do will give us twice the holding power. In this step, we're going to prepare for inserting the wire. So you can see this is flapped over, and there's some staples towards the top. So to do that, we take this top piece and we bend it over. All right, from inside to out. Okay. And then we're going to take our handheld stapler. And I'm going to put a staple in the center, one alongside the nose, and then one in between there. And remember, I put my black mark on the stapler to help guide so I know where the staple is going. So I'm putting one in the center, one along the nose, and then one in between those. And I'm trying to make it as close to the edges of the material as I can, but comfortably within the material. Again, I do the center, do along the nose, do along the side. And for all of these, I'm stapling from inside to out. So the smooth part of the staple is against the face, and the rough part of the staple is pointing outside. In this step, we're going to make the nose bridge. So with the galvanized trim or flashing material, I'm going to cut about a 3/8 strip off of it. And working with sheet metal and wire can be dangerous, so wear eye protection. And you don't know how many gloves I've cut working with the wire and such. So after I cut the shim, I'm going to basically try to flatten it like that. And then this happens to be a 6-inch piece of galvanized flashing width, so I have to go from 6 to 5. So I'll cut it at 5, roughly 5. And then in the center, so I'll lay this down, and half of 5 is 2.5, so I just put my finger at 2.5, and I push up. And I like to bend it around my finger, so I don't get a really sharp bend, so I just kind of get a gradual bend. Okay, a sharp bend is just gonna feel bad against the face. So that's how I make that. All right, now for the aluminum wire, 17 gauge aluminum wire. All right, I just cut off a 5-inch piece. So there, using any sort of wire cutter, cut it at 5 inches. And then you'll want to straighten it out. Lay it down on here, kind of centered it at 2.5. I put my finger, lift it up to get the bend. And then I'm going to try to, again, make a nice round bend. About 60 degrees is what we're after. Now on the pipe cleaner, right? So the pipe cleaners, I don't know what size you get. This one's coming at 1 foot, 12 inches. So I need to shorten it, because remember, we're going to double it up. So to get a 5-foot length, 5-inch length, we have to go up to 10 inches. So we'll cut it at 10 inches. All right, then we need to double it up, put the ends together like that. All right, then we got to twist it. We have to twist it together so it's a little stiffer. Now it's all twisted together. It's going to be a stiffer piece. We're going to lay it down on here, put our finger at 2.5, pick it up, give it a nice gentle bend. All right, there. And now that's my bridge. So in this step, we're going to put in the bridge and basically lock it in place with staples. I'm going to show you how it is with the galvanized flashing. but it's the same process regardless of what other bridges you use. So I start by folding the top flap back, and then I put the bridge material up against the fold, then I bring it forward, so like that. And then what I'm going to do is I'm going to put a staple on the opposite side at the same, basically, location as those staples. And for this one, I kind of start in the middle. So I'm going to do my middle staple. Again, my black mark's going to really help me, and the staple's going from inside to out. My black mark's going to help me align where I want it. You see that? And then I'll come over to this side, and I'll do one at the middle. Just lock it in place. So put my black line past the galvanized staple. All right. Now I can put the other two in. This isn't going to be moving much. Now we're going to put the strap in. In this final step, we're going to complete the mask. And we have sort of a design for the mask here that has like surgeon ties. You have a lower tie and an upper tie. And for this to be enough length, we use a 36-inch piece of yarn or static. If you're going to use elastic, I can't tell you what length to use because a lot of factors come in, basically how much force, how much elasticity. You just have to try a few things. For the different elastics we had, they were all different lengths. But for statics, 36 inches is what it's at. And then we take to put it on, we work with the middle of it. Put the middle on, and we're going to fold this over past this middle staple. We don't want to include the staple in our fold. Fold it basically at 45 degrees with the yarn on the inside of the fold. And then when we staple it, we don't want to staple the yarn into it. But we're going to put a staple here on that corner, here on that corner, and one across. So I'll start with the across one, that's easiest. All right. Then I'll go here and do one that way. And you see that really tacks down that corner well. And then the yarn still moves, which we found was pretty good because we could tie the lower one and then tighten the mask and then tie the upper one. So same deal here on the opposite side. Again, we're going to fold without including that staple in the fold. Lay that there. Fold it over 45 degrees. Put a staple parallel to the fold, then I put a staple that corner. Now we're done, and we'll discuss packaging. In addition to exploring DIY methods of making masks and fitting, we also explored DIY packaging. If there ever becomes a need for DIY masks, we're going to need DIY packaging. What we settled on was a process, of course, where you make them in an environment that tries to decrease contamination as much as possible, cleaning the surfaces, using gloves and a mask. But it's inevitable to have germs in the air, so heating them up certainly helps kill germs. So, and we chose to heat them up at 200 Fahrenheit for 20 minutes. Now we chose 200 Fahrenheit because it would not melt the polyester so comfortably. It would comfortably not melt. And we just wanted the highest temperature where we were comfortable we wouldn't damage the mask. And then 20 minutes is just, in our estimation, was long enough to sort of hit a steady state. So we take the mask, we put them in the bag. Again, this is a bag that's intended to go in the oven or to go in a slow cooker. So this bag is intended to get hot. Trash bags will not work. Trash bags will melt. They're typically made out of polyethylene. So you put it in the oven with it open, and then as it heats up, moisture and gas will escape from the bag, and then while it's hot, after 20 minutes, take it out and roll it. All right, and then that will protect it from further contamination, and then we tape it after we roll. And then put a label on it. So, and then I would stick it in a second bag. So the label doesn't get damaged or soiled as well, and then it's just an extra layer of protection. Roll that up. Tape it shut. That's it.